Hello, I'm Dominic Humphrey. I'm Senior Research Fellow at the Building Stock Lab since 2019. I want you to picture a non-domestic building. What is it? Is it a school, a hospital, an office, a supermarket, or perhaps a factory? This is the building stock that features most frequently in policy and research discourse, where expertise, investment, and policy have concentrated. But what about the non-domestic stock we see most often? The GP surgery, the nursery, the dentist, the pub, the shops, and the offices above them. The sorts of businesses that have been hit hard by rising costs and high energy prices since the Ukraine war. Those that can't commission consultants to give them a net zero roadmap, perhaps aware of climate change and struggling with energy costs, but unsure about what to do, and nobody has come to them with a solution. They're one of the hundreds of thousands of businesses across Britain sitting in a gap that our policy system has not properly addressed, let alone addressed. Too small for large-scale retrofit and not always qualifying for some of the domestic schemes, and certainly not in the public sector. Just sort of in between, sort of gap in our understanding about their energy and demand. This talk is about what happens when you actually count these buildings. For more than a decade, UCL has been developing 3D stock, as Steve previously introduced. It's a comprehensive tool to survey all buildings in Great Britain, down to the premises level in 3 dimensions. Not a sample, not archetypes, but every premises, every footprint, every roof, every wall measured. Last year, we delivered the National Buildings Database for the Department of Energy Security and Net Zero, the largest national scale stock model in the world. And it gave us a capability we hadn't had before, the ability to ask precise physical questions of the stock simultaneously. We asked it one sort of simple question, which of these buildings could physically accommodate a heat pump using the technology that already exists, that you can already buy, and that has been successfully installed in millions of homes across Europe. To answer it, we defined heat pump possible. A building is heat pump possible if it has sufficient external space around it, or wall area above street level, or a gently sloping roof. Any location where an off-the-shelf solution could be installed, and it isn't subject to statutory protections such as listed building. That filter, applied to the whole stock, returns a sort of striking result. Approximately 80% of the non-domestic stock in Great Britain is heat pump possible. 80%. That is not a finding built on assumptions about a typical building. It is a finding built on the actual geometry of all buildings, sort of an individual desktop appraisal of every premises and their unique combinations of constraints and opportunities. But 8% of the non-domestic stock is still a very large and varied population. It includes those hospitals, schools, supermarkets, and factories. Activity types with very different energy demands. The question we really wanted to get to was slightly narrower. How much of that non-domestic stock is domestic in scale? Because here's something that gets very little attention in the heat pump debate. A significant proportion of the non-domestic premises, those sort of small businesses, community centres, private professional practices, have energy demand that is roughly equivalent to a home. Their annual gas consumption falls within domestic metered range. Their heat demand could, in principle, be met by existing domestic heat pumps. Not a bespoke commercial system, not a new district heat network. Products that exist at volume, available now. And when we filtered the heat pump possible stock to include only these premises that are in that gas heated with a combi boiler, and where metered data confirms that they're operating in that domestic range, we arrive at this number, 200,000. That's about 10% by count. That's 200,000 premises across Great Britain that could today switch from a gas boiler to a domestic size heat pump. Physically possible, technically straightforward, financially feasible. operating during periods outside the domestic peak aligned with solar generation. And that's sort of 200,000 opportunities for a policy that could address energy costs, adaptation and transition. 200,000 locations where non-domestic installers get experience with domestic scaled stock without the kind of emotional challenges that come with changing a heating system in someone's home. And yet there's no policy that sees them because we didn't have the data to do so. The boiler upgrade scheme is largely targeted at householders. The industrial decarbonisation schemes focus on large energy users. None of the current strategies or policies focus on this stock. These buildings have been sitting outside the policy conversation, not because decarbonising them is particularly hard, but because nobody had counted them. Nobody had been able to view the stock as a whole and see this opportunity. That is the gap that this research highlights. And it matters because the transition to the built environment to net zero is increasingly not a technology problem. We have the technology, it's a targeting problem. We're not systematically directing policy and investment towards the buildings where it would have the fastest impact with the least friction. So we have spent over a decade asking that question about whether heat pumps work, and the evidence from domestic deployments, trials and performance data now coming through at scale is clear. They work, and in well-specified locations they work very well. So the question this research asks is different. It is not does the technology work, it is which existing buildings can we decarbonise right now? Because the non-domestic stock has been treated in sort of policy terms as either too complex or too large to address with the same tools that we apply for domestic homes. And that assumption is wrong for this section of premises. They're not large, they're not complicated, they are by measurable definition domestic in scale. They just happen to have that non-domestic use. So looking at this chart, what changes when we can see these individually? When we know not just that there are that many, but what they are, what their energy demand profiles look like, what activities happen in them, and because it's a geospatial model, what locations those activities happen at. When we have that, we can start to target, we can sequence, we can design policies that fit, and the 3D stock database opens up those possibilities. It gives us a resolution to do evidence-based policy designed from the ground truth rather than on archetypal assumptions. And that's a different kind of research capability, and it'll offer a different and broader range of policy pathways. So back to the building that we failed to picture, the GP surgery, the nursery, the pub. It is not waiting for a technology breakthrough. It's not a hard case. It's not on a priority list, but not because it's been assessed and discounted, but because it was never on the list to start with. This research puts it on the list. It puts another 200,000 buildings on that same list. The ambition of net zero in the built environment will not be achieved by only addressing the buildings we already know how to reach. It also needs us to address what we're missing, which is what we're doing here. So the question now is, how do we go from possible to planned? Thank you.